Hey pre-calc students, in this video I want to explain how to solve a quadratic or nonlinear inequality using both methods. I got some good questions today, especially about how to use the Calc 0 method. And I want to clarify some points that came up in the discussion with a couple of students. First, let's do the intersect method. And we're going to solve this graphically using the TI-84. The first way is to graph the left-hand side, y equals x squared plus x minus 2. So we'll graph that, and we will separately graph y equals x. So we'll graph those two graphs separately. And so let's do that first. We'll do that right now. Let me switch over to a graphing calculator. Now, you can't see what I wrote, but I will type that here. So first we go to y equals, and in the first graph, I'll graph the left-hand side, which is x squared plus x minus 2. I'll go down to y2, and I'll put in a second graph, y equals x. And let's just see what it looks like. And it actually looks, if I just hit the graph button, it looks like my window looks pretty good. So I can actually see the points. Quick thing, there's a couple ways you can zoom in. If I hit zoom box allows me to create like a box around the window that I want to see. So if you go to the upper left and hit enter, you go down, maybe about there, and you can go to the right. Kind of create a box around what you want to see and hit enter. Now it doesn't make it, it makes it shifts the window to be exactly the box you make, so it might be stretched. Like this one looks like it's stretched horizontally more than it is vertically, but that's okay. Okay, so back to here. Actually, in my graph, the way the TI did it, the linear is red. So if I come back here and recolor this, I could recolor this as red just to make it match what's in the picture. Okay, so you'll notice that what I want is I want to know when is the quadratic, the blue graph, greater than x, the red graph. Another way to think of it is when is the parabola above the line. Okay, so let's go back to this graph. And I can see that the parabola is above the line everywhere to the left of this intersection point. So that would be to the left of about, I don't know, negative 1.4-ish, wherever this intersection point is. And the parabola is above the line to the right of this intersection point. So if I can just find these intersection points, the quadratic is greater than y equals x to the right of this intersection and to the left of this intersection. So we use the calc intersect method to find those values. Let's do that. So you hit second calc, and then intersect is 5. So I'll hit 5, and it asks me to select the two curves that I want to find the intersection point. So I'll hit enter and enter. There's only two curves, so it's going to pick the two you want. And then I want the guess. So let's find this intersection over here. So you can hit the left arrow if that's how you want to do it, and you can get somewhat close. It doesn't matter, and hit enter, and it will snap that little X cursor right to the intersection point, and it will give you the X value. So I'm going to write that down. You can't see it, but I'm going to write this down on the other page. X equals negative 1.414. So I'm going to write that value down, and then I'm going to find the other intersection over here. So you do the whole process again. Second calc, intersect is 5. Now, instead of using the arrow buttons, I'm going to show you that you can actually just type in an X value that's close and then see if, well, it'll find the 0 as long as it's close. So this is about 1.4, maybe 1.5, maybe 1.4. So I'll hit 1, second calc, 5. I forgot to choose the curves. It says first curve, enter, second curve, enter, and now I do my guess. which is 1.4-ish, about there. And then it found it. So the intersection is, and I'll write this down, x equals 1.414. So it turns out they ended up being symmetric. I guess that actually makes sense in this case. Okay. So the x value of the left intersection point is negative 1.414, and the x-intercept of the right intersection point, the x-coordinate of the right intersection point is 1.414. So I can actually go back to here, and I've written those down. The parabola was like this, the linear was like this, and the x values that we found were, this is the x value for this is the x value for this. And we want to know, where is the quadratic above the linear? Well, it's everything to the left of this value, and it's everything to the right of this x value. And so the answer is everything from negative infinity up to the lower amount, the lower value, 1.414. And, I put a bracket there, but then I realized this is greater than, so we don't include the place where the two graphs are equal. This would be parentheses. Now, to represent the interval to the right of this, it would be all the x values greater than 1.414. So that would be 1.414 up to infinity. And I would put a union between the two because we need to union these two intervals. Okay, so back to the picture. All x values from negative infinity up to negative 1.414, but not including it. That is where the quadratic is greater than the linear. And all the x values from 1.414 up to positive infinity is where the quadratic is greater than the linear on the right-hand side. Okay, let's do the Calc 0 method. And here's where some questions came up. And I'll begin by writing down the exact same inequality that we started with. Okay, so I have this inequality and I want to solve it using the TI calculator. I'll begin by subtracting x from both sides because for the 0 method, I want everything on one side and I want 0 by itself on the other side. X squared plus x minus 2. Now, I could combine like terms on the left and that would be totally fine. Just for the sake of being very explicit of what's going on, I'm going to write x squared minus x, or x squared plus x minus 2 in parentheses minus x is greater than 0. I'll just put parentheses here to really emphasize that this was the original left-hand side of the inequality, and this is the original right-hand side of the inequality. I want to know where the difference between the two is positive. And specifically, if I take, since I subtracted the x over this way, I want to know when is this one minus this one greater than 0. Because wherever that's true, then this one will be above this graph. Okay, let's do it. I'm going to go back to the calculator and go to y equals. And what I've put in here already is I've typed exactly this. So I've just typed in what I have on the left-hand side of this inequality, x squared plus x minus 2, and then subtracting x. And you'll see that here. It's x squared minus x minus 2, and then I subtract x. So this is the original left-hand side minus the right-hand side. Hit graph. And now this is the graph of the difference of the two functions. Okay, so back to our handwriting work. We want to know when is this new function greater than 0. Well, if we go back to the calculator, we'll see that it's greater than 0 to the left of this x-intercept, and it's greater than 0 to the right of this x-intercept. So I'll use the second calc 0 function. I want to use the 0 function there. So I hit 2, and it's going to ask for a left bound. We want to pick something to the left of this 0. So how about -2? Enter. And I'll pick something to the right. How about -1? And you'll notice it puts like vertical fences around the x-intercept you're looking for. And now we need to make a guess. So the guess is going to be, I don't know, that's close enough. And it will snap to it. And I'm going to write this down. I get x equals -1.414, 214, but I'll just round to 3 digits after the decimal place. And we'll do the same over on the right hand side, and that answer should look familiar. We'll do the same one over on the other side. I'll hit second calc. 0 is 2. And now my left bound, something just to the left of this x-intercept, would be 1. X equals 1. And then right bound, x equals 2. And the 0 I want is in between. I'll just hit the left arrow a little bit so it's close enough. It doesn't really matter. Once it's close, we'll get it. And the other 0 is x equals 1.414. Okay, so remember, we want to know, when is this graph greater than 0? And so that is great. That is true when you're to the left of this intercept or when you're to the right of this intercept. So our graph now looks like a parabola that looks like this. And this x-intercept is x equals -1.414. And this x-intercept equals 1.414. And so the solutions, when is this positive? The solution set is all the numbers from -infinity to -1.414, union all the numbers from 1.414 up to positive infinity. And that should look familiar to our prior answer, because we were doing 2 different methods to solve the exact same inequality. Okay, this looks very similar to how we did it by hand. It's just that the calculator is finding the zeros for us and is actually doing the test values for us. So it's kind of like doing the sign charts for us automatically, and we're doing it visually using the graph. All right, I'll see you in class.